Yeah, welcome, and thanks for the opportunity for me to introduce a perspective from the German 6G Lighthouse Project. My name is Gerhard Kunzman, and I'm leading the work page 1 on architecture as part of this initiative. So, first of all, what is 6G ANA about? What are our ambitions? So we are setting forward to strengthen and push the German and European industry. So we are quite a strong. We have quite strong industry engagement in our project. We want to provide an opportunity for the industry to enable dissemination, not just from the academic part, but also for the industries. We drive global pre-standardization activities from a basically German, but also a European perspective. And for this purpose, we have set up a so-called system engineering gremium that will look into standardization aspects within the project. And as part of the larger 6G platform in Germany, we are also supporting other German 6G projects with this effort. Another ambition is also that we want to strengthen and push German and European technology sovereignty. How this is achieved, we do have, as a Lighthouse project, a very close interaction with other national and international activities. So within Germany, the mentioned 6G platform, but also the 6G hubs, where the academic partners are organized, and also other industry projects. On the European level, joint effort with the Hexa-X-II, like we have now the opportunities to speak in your workshop, the SNS joint undertaking, and others. On a more European national level, other projects in Finland, Spain, Sweden, France, where we interact with, and also then through our partners, we have insights and interaction with other international 6G programs like the Next G Alliance, IOWN, etc. The project was kicked off mid-2022. It has a duration of 3 years, so we are roughly halfway through the project. Before I go into the technical details, I would like to give a very short glimpse at the project partners. And I think this is also one of the strong parts of the project here, where we have a good collaboration of industry players, also competitors like Siemens and Bosch working in similar areas, Ericsson and Nokia, so where we all come together to discuss very openly. We also have quite a lot of small, medium enterprise companies which see a benefit of joining this Lighthouse project, even for their research staff being rather small. They see a benefit of joining the efforts in the Lighthouse activity to promote their work, to make their voice heard towards the 6G vision. And then, of course, the different academic players completely distributed throughout Germany. What I would like to highlight here is maybe that there are these 4 6G hubs in Germany. So topic-wise aggregation of certain academic partners. And we in the project, we have at least all the leads of these 4 6G hubs also part of the project. So we have also very good visibility also here on the academic work. In addition to that, there are also 3 associated partners. So partners that join the project have signed the NDA, but don't receive funding in the project. A bit different to compare to what the Hexa-X and other projects maybe is that, I mean, our focus is not mainly dissemination as the first means, but we have a quite closed consortium, so we can very openly discuss and exchange other views from the different partners within this project. Some of the information that we want and can share is, of course, about the project context and the vision. So basically, our idea here is that we would like to connect the worlds. Maybe you have seen that before. So basically, we believe there are these 3 worlds: physical world, human world, and the digital representation, the digital world. And there are connections between the different worlds. So the digital world provides an augmentation and the possibility for digital twins representing the physical world. The humans and the physical world, they will work together in a collaborative environment. Humans working jointly with robots, with the machines, getting even closer now in our factories. And then the digital world and the human world, where here additional intelligence and cognition can help to enrich our human perception, our human world by a digitalization. The project is now structured within this circle of these three worlds. Here you can see in the center, there's the work package 1 that I'm leading, which is looking into 6G architecture and system design. And we have a second work package here looking into 6G access technologies and spectrum. We have one work package looking into network of networks, and a fourth work package on automation and simplification. All of these work packages have some common design goals that are sustainability, which is a key design goal for the 6G, security and flexibility. In addition to those four more technical work packages, there is also a fifth work package, which is developing testbeds, POCs, demos that wants to demonstrate the work that we do, show that the concepts that we develop are feasible, but also then provide a feedback loop back into the technical work packages, measurements and results or findings that could be achieved during these testbed setups and experiments. In the next couple of slides, I would like to go a bit more into the details of the technical work packages, starting with the work package 1 on architecture and system design. So what are our objectives or work areas here? So first of all, and in the beginning of the project, we started looking into use cases and requirements. When we started the project, there was already a quite rich set of use cases available from other projects, like the use case families from the Hexa-X project. And also some of the project had already started to also define requirements. What we did now is we evaluated that, but we tried to also extend these use cases with, on the one hand, project-specific use case areas that our partners introduced, but then also we didn't want to have this very broad range use case families, but we wanted to have very concrete and detailed use cases that we could then also test whether our architectures that we could show in our demos and so on. So going a bit into the opposite direction, maybe. Then in the second step, and we are in the middle of this, is to define an end-to-end architecture from a functional and a deployment view, based also on the outcome of the initial results from the work packages 2 and 4. And yeah, as I said, security is also one of the key aspects that we are looking into this project. We want to also show that this architecture can fulfill the security requirements that are set forward with the 6G. In order to better understand these security impacts, we have done a threat and risk analysis. As you can see here on the right bottom part, we had a poster last year at a German national conference on IT security, where we analyzed different aspects, different areas where security need to be addressed in the 6G area. Then, as I mentioned before, we have these sustainability aspects. So, of course, as a very important design criteria, we need to make sure that our network design is sustainable, that we can, wherever possible, reduce the energy usage in our systems and improve the overall efficiency of the system compared to a 5G baseline. Yeah, and then I mentioned before that also in the work package 1 scope, we have set up this system engineering gremium, which is a subset of the partners that try to also understand which results from the 6G ANA project can be best brought forward towards 6G pre-standard and standard activities. Let's have a look a little bit into an initial 6G functional architecture view that we developed in the 6G ANA project. You have seen similar graphics already today in the workshop presented by other projects. Maybe starting from the bottom, there's the infrastructure layer with the cloud, with the underlying platform, etc. This is not so much in scope of the 6G ANA project, but then going up a little bit here into the center part, we have the radio access networks and the core network, maybe worth highlighting here is that we anticipate that there will not be a dedicated 6G core network, but rather there will be more like an evolutionary approach to the core, kind of G-agnostic core network, where based on the existing 5G core, some new network functions, some new services will be introduced in order to support the new 6G run and other services that are introduced in the 6G timeframe. Then on the 6G run, you will see tomorrow a dedicated presentation on that one by my colleague Torsten Duda from Ericsson. So I also not go into details here. In the backdrop layer here, in this light blue color, there's the network management layer. Of course, each of these boxes here comes with a management plane. And within this network management plane, one of the areas or aspects that we are looking into the 6G is this network digital twin. And I'll have also one more slide on that later on. On the left-hand side, you can see then the different devices, 5G, 6G, or maybe some devices also supporting both access technologies that are connecting then here to the 5G and 6G radio access network respectively. You can see here also this dark or light gray circle, which is labeled as a 6G subnetwork. I will come back later to what is a subnetwork, but maybe in a glimpse, a subnetwork is a specialized and localized subset of the overall 6G network, which has also specific characteristics. Then on top of this, we believe going forward with 6G, more and more exposure capabilities of the network of the functional blocks will be provided. Exposure from the RAN, from the core, like we have already now in the network exposure function, and of course also exposure from the network management plane. And then these network APIs, they can be consumed by developers and applications and their users residing in the application layer. Here in the application layer, there will also be these new services like the digital twins, XR, Metaverse. I have some more information on those coming up. But then, yeah, what we foresee also for the 6G is that, yeah, not all the developers, not all the application users understand, let's say, this a bit more complex and telco-specific network APIs with all their complexities. So we believe that there will be a middle layer here, a platform, a value-adding network platform in between that will provide more simple APIs towards the developers and the application users and the applications so that they can configure or get information about the current network status. And this is also an opportunity where here maybe the mobile network operators can also monetize their network. Then jumping from this functional architecture view to a bit of the timeline, we have already since a couple of years different organizations, projects looking into research towards 6G, Hexa-X-II, for example, in the US, the Next G Alliance, in Germany, then, as I said, this 6G ANA project that was launched mid-2022. There is also a lot of industry alignment already ongoing to prepare for the 6G. We had, for example, this World Radio Conference end of last year, which had an agenda item on the new bands for 6G. Now we are here at the beginning of 2024, and this is also the time where now the standardization activities are getting kicked off. There will be a first workshop in SA1 in 3GPP to start preparing for the 6G studies. That will then look into Working Group 1, SA Working Group 1, at least 20 requirement studies, followed by architectural studies in the SA2, and also in the radio access network, technical studies will be kicked off, likely with a 6G workshop that will take place beginning of next year. But going a bit forward, then we expect that a first set of key 6G architectural decisions will be available as a first release 21 package by the end of 2026, followed by then more SA and CT specification work, and also on the run side, specifications will be developed so that the first 6G specification will be available around the end of 2028, which means that we would then be ready, or we anticipate that the first commercial real 6G deployments based on these specifications will become available like 1 year later. Let's move on to the next work package, 6G access. Here you can see also a nice architecture view zooming into the cloud run aspect that is being studied in the 6G ANA. This work package 2 looks into interworking and spectrum usage, the PHY aspects, and then, as I said here, about RAN protocols and cloud-based architectures. I will not go into detail here, but I would like to promote this session taking place tomorrow morning as part of this workshop series, where my colleague Thorsten will talk specifically about the results and the work scope of this work package 2. With that, I'll move forward to the network of networks, work package 3. So this is about providing secure and reliable and flexible topology for our 6G architecture. And one of these subtasks is here, the so-called 6G subnetwork, which is kind of an integration of mobile networks combined with a device-to-device communication network in different deployment scenarios in different flavors. These integration aspects cover maybe different access technologies, but having a joint like identification and authentication scheme behind it. Purpose is that these networks should be flexible, reliable, maybe even providing a certain level of autonomy, and they need to be, of course, secure. Let's look a bit more into these use cases of this network of network or the 6G subnetworks, maybe first focusing on the left-hand side of the figure, where you can see here this diagram, where I would like to show that these subnetworks can come in many different flavors. On the x-axis, you can see that there can be some 6G subnetworks that are super local, very small local proximity only, like sensors on a robot, for example. They can also be very specialized. And at the other end here of this dimension, there could also be this larger area networks on a more regional level, for example, drones operating in a certain state or in a certain factory premise. On the y-axis here, you can see this hardware abstraction dimension. Again, here we can have these very specialized devices with very small capabilities only, or we can go up to a very high hardware abstraction layer where we have very complex devices like smartphones, AR glasses, machines in a factory, or then also many people gathering together, for example, in a stadium, forming then here a local subnetwork to share video streams from the match going on here. On the right-hand side in the figure, I would like to highlight one aspect, which is also for us key of these subnetworks, is that these local subnetworks, they are never operating completely autonomous, but they are usually working in cooperation with a wide area main 6G network capability. So they are a sub-network in that sense. They have the characteristics that if the connectivity here to the main network or the wide area network would be lost for a short period of time, could be a disaster use case, for example, or just bad connectivity because the car or the bus, the train is going into a tunnel where the connectivity is lost for a couple of seconds or minutes, then this subnetwork has some capabilities to still operate and provide connectivity among the devices in the subnetwork during this autonomous operation mode. With that, let's move on to the next work package, automation and simplification. Here there are 4 different tasks. Task 4.1 is mainly looking at these traditional management and orchestration aspects, how we can develop further all this data-driven reconfigurable management and control aspects going forward with 6G, and how can this be done also with a very high level of network security. Then 4.2 about digital twins and extended reality. 4.3 about distributed applications and AI aspects. And again, a dedicated task on sustainability and trustworthiness, as these are really two key aspects. So extra effort done here on this one. In the next slide, I would like to look a little bit more in this task 4.2 digital twin to give a short definition of what is a digital twin. So first of all, there can be a digital shadow. A digital shadow is a kind of a virtual replica of a real-world system where changes on the real world that are observed are updated in this digital shadow. So this is more like a read-only version, one-way information flow, but you can still already do certain analysis and certain simulations, what-if analysis based on this digital shadow. Yeah. Then a more advanced version here would be this digital twin, which is again this virtual replica of the real-world system. But here you can perform really operations on this digital twin, and then maybe also you can feedback or mirror those operations back into the real system. So this is more like a bi-directional activity then.
Yeah, if you could wrap it up.
Yes, I'm going faster now, almost done. We have then this geospatial digital twin type 1 and 2, which is a bit more photorealistic version of the digital twin. And then we have also this network digital twin. I think this is also one of the important parts here for the architecture for the 6G, which is then a specific digital shadow or digital twin of the communication network itself. Yeah. And all of this together, this is needed also for the industrial metaverse. Yeah. Last slide on the work package 5 on our demo and testbed activities. One example that I picked here is on the mobility metaverse, where we showcase a combination of a 6G subnetwork together with a digital twin. You can see here at the bottom this real world environment with cars driving around, and you can see the real-time digital twin here on the screen in the top. And what you cannot see in the digital world here, if you come from this direction, from this view angle, is that there's actually one more car hidden behind this tall building here. Maybe this information could then be used to increase the safety of the car system. And this POC was demonstrated a few times already, amongst others, at the Digitalgipfel in Germany, which is a summit organized by German government on digital transformation that took place last year in Jena in Germany. Okay, with that, I'd like to thank everyone, and I provided a few links to the project, to the 6G platform. And also, if you want to read a bit more about the project, there is also a paper that we published last year in IEEE Access.